So first, let's think what is an interface and what is a protocol. So to understand that, I would say that the protocol defines the rules of information exchange and the interface is a medium. Welcome at Riverdi University. My name is Kamil and I'm CEO and founder of Riverdi. Today we will talk about display interfaces. I will try to organize for you what kind of display interfaces we have and how they differ from each other. So I hope after this video this will be clear for you what kind of external, internal interfaces we have and what their main purposes, let's say. So first, let's say the deviation of the interface, we will have like internal and external. So internal means we use them inside the device, so they are usually embedded interfaces that we don't see and we don't have access to as a user of the device. And we have external interfaces when we connect device with each other with the cable. And once we will have this internal and external interfaces defined, we will see that inside this we have universal interfaces and we have image transfer interfaces in both of the categories. So first, let's think what is an interface and what is a protocol. So to understand that, I would say that the protocol defines the rules of information exchange and the interface is a medium. So the example here will be the language. Right now I'm using my voice to communicate with you and my voice is an interface. So over this interface my voice is being sent to your ears, but the protocol is the language that I use. So right now I use an English protocol. So English language is my protocol. If you understand the protocol, then you understand what I'm saying. If I will switch to other language, if I will be speaking Polish or some other language that you don't understand, you will have the same interface. You will still hear me, but you will use different protocol. You will not understand me anymore, yes? So today we will talk only about interfaces, how to connect devices to each other like a display, but we will not talk too much about the protocol. This is separate from this video. So let's first try to organize interfaces a little bit. So as I mentioned, we have universal interfaces and image transfer interfaces for internal interfaces. So the interfaces that are embedded into the device, and universal mean we can send other data through them, not only image. And because they are universal, they are usually not perfect for image transfer, because in most of the displays that we use nowadays, the image transfer is one of the most demanding. So the bit rate, the data transfer for the image usually is very high and higher that many universal interfaces can give us. But if we need to send like image only once per some time, we don't need very high bandwidth, we don't have the live video, for example, then we can use some of the internal universal interfaces such as SPI, I2C, or even as slow interfaces as RS-232 or UART that are very similar. So this is the first slide to organize a little bit the interfaces, and let's jump into more details. So first, universal interface will be SPI. That is a serial peripheral interface. So that means this interface is a serial, of course, and it's used to communicate between a host, the master called in SPI, and the devices that usually we call slave. One host can communicate to many slaves. To select the slave, we use the chip select or SS line, and then we use two data lines, the master output or master input, and of course the clock to synchronize the data, because this is the clock synchronized interface. It can be fast, but not fast enough usually for the live video images. So we can have, baud rate here like 1 megabit, but can be like 10 megabit or even 50 megabit on the SPI or QSPI, which is a quad SPI kind of modification of SPI that is faster. But still, this interface is very universal. So use it to connect memory or some input-output ICs in between internally of our device. Yes. SPI in a display world is used for a simple displays, for usually the small sizes displays, where we can transfer the image relatively fast because the resolution is low. So I would say that the maximum here for SPI display would be maybe 3.5 inch 320 by 240 TFT display. If we have higher resolution, usually the image transfer will be too slow to use SPI, even with high-speed SPI. Then we have the I2C interface. This kind of interface is usually slower than SPI. It uses only 2 lines, so one is clock for synchronization and the other one is a data line, and then data line here is bidirectional. So in SPI we have 2 data lines, one outgoing and one incoming, and in I2C interface we have only 1 data line. So if, for example, master is sending some data, the slaves can only receive it, and the master then need to finish it. We need to wait a little bit, then we can respond as a slave to the master. And here also to select the slave, it works a little bit different, because in SPI, as you remember, we had this chip select line, CS line or SS line, and here we need to send first the address, the logical address we need to send to the interface that is being written by the slaves. In general, this is slow and universal interface used also to connect maybe the simple memory and some other ICs that we have around our microcontroller on the PCB. Very useful, but usually not used for the image transfer. This interface is very popular in a display world for the touch screens. Yes, so most of the embedded touch screens that we use, they have I2C interface, because the touch screen do not generate many data. We have only coordinates of the finger or few fingers at most that need to be sent back to the microcontroller, to the processor of the device. So the slow baud rate is well enough for the touch screen, but not enough for the image. Then the next interface, a very old interface nowadays, is RS-232. So this is also serial slow interface that can be used internally in the device or externally. Actually, this interface is not only internal, can be external, and we see the external connectors here, but it's still being used internally because it has its variation, that is UART. So UART is basically the same as RS-232, but it's a fully internal interface, pretty slow. We have a TX line and a RX, that is a transmit line and receive line. We don't have a clock here, we only have a clock as a synchronized internally into the devices, but the clock is not being sent out. So we need to synchronize with the data that is coming through the lines, and to do that we actually need to set the same baud rate on the sides of the communication line. So before we use UART, we need to agree first what speed we will use. That is not a case in a SPI or I2C, because we have a clock there, and the clock there gives the speed to everyone. Yes, so everyone works according to the clock. In UART we don't have a clock, so first we need to agree what speed we will use. UART is rather not used for the image transfer, or it's very slow. So maybe UART or SPI or I2C, they can be used for displays, but for as I mentioned, low resolution displays, could be SPI, but for high resolution displays we need intelligent display. So we need a display that will generate the image internally, and through this slow universal interfaces we only send commands, or maybe we send image once and it's being stored into the internal memory of intelligent display that we will use later, sending the right command. Yes, so intelligent line of displays, you can find it on our website. We have very advanced intelligent displays made with a BridgeTech controllers. They use SPI and QSPI for communication. That means your software, your system, your microcontroller can be simple. You can use SPI interface to drive them, and still you can have high resolution, even as high as 1280 by 800 in a 10.1 inch display with the relatively simple microcontroller and a simple software to drive it. So as I said, if you want to use a slow universal interface, you need to use intelligent display. Then we have the internal image transfer displays. So what does it mean, image transfer interface? It means that we can transfer the image continuously with a very high speed, high enough to refresh the display many times per second. Yes, so this is called a refresh rate of a display. If you will go to the display specification or even a monitor or TV specification, you will see something like refresh rate or maximum refresh rate that this display can receive. So if we, for example, have 60 Hertz, that is 60 times per second, or 100 Hertz for more advanced displays, then that means that we need to send the full image 100 times in every second. Yes, and if we imagine how much data it is, we need to multiply the resolution of the screen. So for example, for 7-inch here LVDS display will have 1024 by 600, so more or less is 600,000 pixels of these screens. But actually, if you remember from my TFT lecture, we don't have pixels in a TFT. Actually, we have a sub-pixels, so we have even 3 times more. So 600,000 pixels multiplied by 3 give us roughly 1.8 million sub-pixels, and to every sub-pixels we need to deliver the data about its state, on and off, but also about its brightness, and usually it's 8-bit. So we have a lot of data. Actually, let's say it's a 2 megapixel display, sub-pixel display, and 8-bit. So we need like 16 million bits per second, not per second, per frame to be transferred. And as I mentioned, if we have 100 Hertz refresh rate of a screen, we need to do it 100 times per second. Yes, so this kind of interfaces, image transfer interfaces, they need to be really, really fast, and they work in 100 megahertz baud rate or even a gigahertz baud rate to be able to transfer this amount of data in every second. So LVDS interface is the most common nowadays in industrial displays that we that not only we sell but that are used worldwide, and it's a low voltage differential signal. It's a very important feature of this interface, that is a differential. Yes, so if it's differential, that means we can use a twisted pair, but even if we don't use a twisted pair of the wires, still differential signal is very immune to the noises. Yes, so that means we can send data really fast, and we are not let's say, broken by some disturbances, as you will see in other interfaces is quite common. So for now, please remember only that differential signal allow you to send the signals with a very high speed and be safe from the noises. Yes, so LVDS is the most basic and common interface for that. The next image transfer interface will be actually the older interface. It's called RGB, from the colors from red, green and blue, of course, that we send parallel to the display. And this interface is not differential. So this one is more, it's easier to disturb with the noises, RGB display than LVDS, and also you cannot go too high with the speed of this in this interface. So LVDS is a serial interface, RGB is a parallel interface, but it's not differential. It's the biggest difference is that it's not differential. So as you see, we send all the data all the time, but we send every bit in a separate line without the pair of the bits like it is in the LVDS signal. So in theory, this interface could be very fast because we are sending a lot of data, but actually because it's not differential, this speed is limited, and usually we find the displays with RGB interface only up to maybe 7-inch or 10-inch. The 12-inch is total maximum, but 12-inch, if you want to find with RGB interface, the resolution will be lower, usually like 800 by 600, so very low for this size of a display. That's why 7-inch usually is like a size that is being switched from RGB to LVDS, and you can see this in our products. If you will go to Riverdi website and you will go to the IPS displays that are displays without the controller, you will see that the small displays like 3.4, 3.5, 4.3 inch, 5-inch, they are RGB interface. Then if you will go to 7-inch, you will find RGB, but you will also find LVDS and MIPI display. I will talk about MIPI a little bit later. And also, if you will go to the 10-inch, you will find only LVDS display, because our 10-inch is a high resolution display, 1280 by 800, and it's impossible to build it with the RGB interface, so we use only LVDS. So please remember, RGB is rather low speed, not very immune for the noises. Of course, it's stable if you don't use high resolutions, and available for the smaller size of the displays. And next interface here, like internal embedded interface, getting more and more popular right now, is a MIPI, so multimedia interface, actually mobile industry processor interface, to be precise. And this kind of interface is used usually, as the name it suggests, in mobile applications. Yes, so in tablets or mobile phones, in some laptops as well. But as I mentioned, this interface is getting more and more popular, not only in the mobile applications, but going into industry as well. In Riverdi offer, you will find a 7-inch MIPI display. But be careful with the MIPI displays on the market, because many of them come from the mobile phones or tablet market, and then the glass availability, the TFT glass, may not be stable. Yes, so please double check what you are buying, because the display with the MIPI that you will buy nowadays may be phased out pretty soon, when the mobile phone built on that will be phased out as well. So this market change really fast, like every 6 months or every year. So if you will buy 7-inch Riverdi display with the MIPI, you are safe, because this is industrial display. That's why we have very limited number of MIPI displays, just one now, and planning maybe 2 more, because we want to be sure that what we have on our website is always available for a very long time. Yes, longevity is one of our core values. We don't want to deliver anything that will not be supporting maybe 3 or 5 years later, because we know many of our customers are building industrial devices or medical or military devices, and they expect the displays to be available very long. But MIPI is a very important and growing interface in a display field. Then we have a V/1 interface. It's not very common. It's a very high-speed interface, also LVDS kind of interface like MIPI, so low voltage differential signal. But V/1 is usually used in a high resolution screens, in a large screens. Yes, so if you will buy, for example, 55-inch or larger 4K TV right now, probably interface inside will be the V/1, the embedded interface. Yes, so V/1 very fast interface for a high bandwidth, so with the high refresh rate and high resolution displays, as I mentioned, usually 4K and above displays. Then we have embedded display port display, so EDP in short. We call it like a new LVDS because many new industrial displays are coming with the EDP. If you will go through industrial manufacturers of the TFTs, you will see that there are more and more models available with the EDP, and EDP is a native interface that you can find in some of the new processors. Yes, like Intel or ARM based processors, they may have already embedded display port as a native display interface. That means you don't need anything extra to connect display to the processor, so it makes the cost down. Yes, so we have a processors on the market, so we need a displays on the market with embedded display port. And I would say that many laptops, I'm sorry, right now, or monitors, they are using embedded display port as an internal interface instead of LVDS, but LVDS is still popular, and I would say that in industrial displays is the most popular. It's kind of LVDS display because all of them, and that is a MIPI, V/1 or EDP, they are variation of LVDS. Of course, the protocol are different, the signals are a little bit different. So for example, for EDP we can have lower noises or like reduction of power, etc. Yes, so all of them have some advantages over regular LVDS, but all of them are actually LVDS type. Yes. And now we can jump into the external interfaces. Yes, so we had many internal interfaces, like some of them were universal, like SPI, I2C, UART, and image transfer interfaces, very fast interfaces like LVDS, RGB, that was parallel one, MIPI, V/1, and EDP, embedded display port. And here we have external ones, the ones that we usually have access to. So for example, it can be HDMI. Yes, so with HDMI we can connect our computer with the monitor or TV. Then DVI, usually used for monitors only. VGA, that is an old image interface for monitors, and DisplayPort. It's like a new HDMI, let's say. And universal interfaces I put here on the USB or USB-C because it's the most common and universal interface nowadays to connect devices to each other. So let's start with the universal one, that will be USB, and particular USB-C, because I think it's one of the best interfaces that we ever designed, because this interface finally, I would say USB Alliance did it. It's a really fast one and very universal. That means it can not only transfer the data, but because it's fast, it can also transfer the image because it's fast enough, and it also can transfer a lot of power, actually up to 100 watts of power, because we can increase the voltage. Like regular USB, you know, maybe it's usually like 5 volt power and maybe half amp power or like 1 amp, so few watts only. and for USB-C we can go with the voltage as high as 20 volt with the 5 amp in total, so we can have even 100 watt of power. That means this interface is not only for data but a real power transfer, so we can not only maybe charge our phone, but we can charge our laptop through USB-C. So if you will buy the new laptop right now, maybe you will not have the regular power connector, but it could be USB-C only. And the USB-C is a very smart interface. So if you connect two devices, they can negotiate with each other which one has more power. So if, for example, we'll connect the charger to the laptop, the charger of course has more power and will charge the laptop. But if we'll connect laptop with the same interface to our mobile phone, then they will discuss with each other, and of course the laptop will be charging the phone through the same interface. So it's a really smart interface to be used, and as I mentioned, it's very fast. So from our point of view, the fast is important because we can build displays with a USB-C, and actually you can find already on the market, they are very popular, monitors that will not have HDMI anymore but will have only USB-C. And this kind of monitor you can even power, yes, from your computer. So some of the monitors, maybe not the large ones, they may have only one cable, so only like both for image transfer and for power from USB. So the future, for sure, in the future we will see more and more USB-C use cases, and this interface is really fantastic in my opinion. Okay, and then we will jump from universal USB interface into the image transfer interface. First one, the most common on the market, of course, is HDMI, so high definition multimedia interface. Multimedia because it transfers not only the image but also the sound, of course. So if you will connect your computer to your TV, you will have just one cable for both, yes, for video and for sound. And this is HDMI. And we have few variation of the connectors. We have standard HDMI, then we have a mini HDMI and micro HDMI, so a little bit different connectors, but the pinout and everything else is the same, yes. So popular and easy to use interface. Then the next one, we have a DVI, so like digital visual interface. The first DVI was not a multimedia interface,